Hi everyone, welcome to AWS Data Engineers Training Program. And today we are proceeding towards a new section, that is CICD. So now today's class and upcoming classes, mainly this week, will be dedicated for CICD related topics. So what CICD is all about and what are other topics related to it, will be exploring. So the agenda for today's class is overview of CICD. Then we'll talk about the CI part, that is continuous integration. And after that, we'll talk about CD part, that is continuous deployment. And then we'll talk about how different tools are there for CI CD. And after that, we'll talk about Git, and we'll talk about Git concepts, and we'll talk about mainly used Git commands. Okay. So CI/CD is very, and you can say, a hot topic, and you must have heard this terms multiple times. So CI/CD is like a end-to-end pipeline where you make the code changes and you commit into the Git, and after that, continuous integration and continuous deployment will happens automatically. As the name indicates, continuous integration means your new code change, whatever change you are making, that should be integrated with your existing code and it should not create any issue. That means continuous integration. And continuous deployment means whatever new change you are making, that should be deployed immediately and automatically without any manual intervention, so that every small change you can deploy easily. So how to achieve those both things we'll be exploring in much more detail. Okay, so let's talk about CI/CD overview. So as the name indicates, CI stands for continuous integration and CD stands for continuous deployment. Using CI/CD, we can have more frequent releases. If I talk about few years back, if I talk about my project, right, we usually had one release in 3 months. That means entire 2.5 months we will keep on doing the development. Then we'll go through testing process, we'll go through UAT process, we'll go through some sign off process, and finally we'll be deploying it. That means anything is missing or any new enhancement, any bug fixing, that will be deployed after 3 months, sometimes even more than that. I have even worked in some projects 10 years back where the releases were like hardly once a 6 month. But nowadays, with the help of CI/CD tool, you can have more frequent releases. Like if you have a small change and you want to deploy that, you don't need to wait for 3 months or 6 months. You can even have multiple releases even in single day. You can deploy multiple times within a week. That also you can do. So using CI, that is continuous integration, we can make incremental code changes frequently and reliably. As I said, your current code is working fine. That is integrated and tested properly and deployed. That's working successfully fine. Now I'm making a small change. Definitely that small change should not affect my existing functionality. It should integrate with existing code in a proper way so that it is not affecting the existing functionality. That is known as continuous integration. Build and test steps triggered by CI ensures that code changes merged into the repo are reliable. How do we sure that whatever small change I am doing, that is not affecting anything? So for that one, we define few test cases. And as and when you are making any change, those test cases will be running. Those test cases are the way to check the functionality. That means after you made any change, if any functionality is breaking, that means some of the test will fail. Suppose you have defined 10 test cases, okay, and those 10 test cases were running fine as per your previous deployment. Now this time you made some code change, and as soon as you will integrate that code with existing code, those 10 test cases will run again, and maybe possible that out of 10, two test cases are failing. That means the code change made by you is causing that one. So we will not proceed with the deployment, and you have to review your code again to fix those two failed test cases. Okay. The code is then delivered quickly and seamlessly as part of the CD process. CI process is only for integration and checking the integrity, whether your code is working fine or not, whether your code is causing an issue or not. If that is perfectly fine, after that, deploying it, continuous deployment part will be taken care by CD process. Now, what is CI, what is CD? On a high level, you understand, and in detail, we will be exploring in upcoming slides. So, before I jump to the next slide, I am stopping here for 2 minutes, and in case you have any doubt, you can ask me.
Sir, in this CICD, there is no manual intervention or like.
No, there is no manual intervention. Only thing you have to do is make your code changes, because as per the new features or what is your enhancement, definitely you will be making the code changes. Once you commit your code changes, that's the only thing you have to do. After your code is committed into your Git repository, everything else, that is integrating your code with the existing code, then doing the test cases, and finally deploying it, everything will be taken care by your CI/CD process. We'll throw more light on the upcoming slides.
Okay, sir.
You can see this one. This is the CI/CD life cycle. So we start with plan, because we plan for something. Your project is there, and you are planning to add some features to your project or to your product, right? So after the plan, you will do the coding part. After code, you will build it, because the code is always in a text format. If you are writing Java code, Python code, Node.js, SQL scripts, those all are in text format, right? So we need to build it. Building means you need to convert that text code into an executable format, into a deployable format. So that part is known as build. And then we have to test it. We have defined few test cases, and we are thinking that if those 10 cases are failing, passing, that means my code is working as expected. You can add as many test cases as you want. You can try covering different possible scenarios, success scenario, failure scenarios, all possible scenarios, so that before you deploy, you have your all test cases running perfectly fine. After test, we'll plan for release, and then we will be deploying it. Deploying on a server like dev server, stage server, production server. After deployment, you will be operating it. That means you will start using it. And along with that, you will start monitoring. The end user, as are operating this, end user will be using your new software or new website, new product. At the same time, you will be monitoring that. You will see that what are the performance statistics after making my code change. Is that working as expected? Performance wise, look wise, functionality wise, you will be monitoring it, and maybe you will come up with few more enhancement. Because nowadays with this agile methodology, what we do is we do not build a very big project in 6 months and deliver in one go. We don't do that. It may be possible that your client has requested to develop something, and as a developer, we might not have understood the requirement completely. I mean, not 100% accurate, right? So after 6 months or after 1 year, if you are delivering something that may not exactly match the client's requirement, client will say, no, I did not expect this. Why did you add this feature? Or I was expecting this window as small, why this window is big? And this feature was not, there can be some mismatch in the requirement and the implementation. So as per the new and nowadays agile methodology being used, what we do is, instead of delivering the project at the end, we'll deliver the project every single week or every 2 weeks, very with minor changes. So we build the product, very simple product with very basic feature, maybe very minimum workable solution, and we will showcase this to the client. The client will, okay, yeah, I understand this one, I am expecting. And if something mismatch, he will say or she will say that, okay, in the next version or the next cycle of release, make this correction, add this feature, delete this feature. He or she will give some suggestion, right? So it's more, I can say, user, developer and client, they are more in sync, because they can communicate easily, and they can demonstrate their product every 2 weeks, depends upon the sprint duration. In my case, the sprint duration is always 2 weeks. So every 2 week we will make some enhancement to the product, and then we will showcase that. So that's why this is a continuous process. So you start with planning, then we'll do the coding, then build the code, testing, release, deploy, operate, monitoring it. After monitoring, you will come up with some more enhancement. Client will say, okay, this looks good, but I want one more enhancement. I want to add one more feature. Then you will plan it again. You will again code, again do this one. So with help of CI/CD, this continuous integration and continuous deployment, or you can, in simple words, I would say, releasing the version more frequently. Maybe every week or every 2 weeks, you can deploy your projects. That's possible. Okay. This is even much more detail. So as I was explaining that you have a code change, which you will make in some text file, that can be Java, Node.js, SQL Server, and you will commit that code into the Git repo. What is Git repo? I will explore. I will explain that as well. But I hope you are aware that any code versioning tool, Git is one. You can use many more. So any tool which you are using for your code versioning system, you will commit your code there. Commit means you will submit your code changes, and there will be some related code as well. Because out of 10 files, suppose there are 10 files in your project, out of 10 you are working on only on 2 files, so you will be committing your changes only on those 2 files. Remaining 8 files you are not doing anything. So your code change, whatever you changed, and along with the related code, that code will go to the CI pipeline, continuous integration pipeline. It will do few things. It will build your code, as I told you. It will convert your code from text format to deployable format into an executable format. Then unit test case will run. So unit test case functional, check the individual functionality. Sometime what happens is, individual components are working fine, but when you are integrating them, then it's not working. Suppose your website has a one section where you can place the order, and once you click on order, it will go to a payment gateway of a particular bank, and you can make the payment and all. So your website is working fine, and even the bank's payment gateway is working as expected. But when you will integrate it, then only you will come up with some challenges, and accordingly you have to fix it. So every project should have unit test case and integration test. Integration test will test the functionality between multiple components. So once all these things works fine, then we are good for deployment. Then we will review it. Someone will review. Maybe some manager or architect or a senior developer. He or she will be reviewing your code change. That whatever code change you are making, is that as per the expected one, as per the client's requirement. Along with that, is it as per the industry best practice? And finally, staging and production. Staging means you will be deploying into staging server, so that you, before you actually deploy in production, you can deploy in stage and you can do your testing, and so that you can understand that it's working fine or not. Because staging environment and production environment is usually very similar, very near one. Development can be altogether different, because in developed environment, every developer is doing a lot of stuff. So testing in development will not give you the guarantee that it will run perfectly fine in production. But stage, on the other hand, it's more closer to production, and there is no manual development work happening on staging environment. So it's best practice to deploy your changes in stage environment, verify that, test it properly, do the UAT, and once deployed, you are ready to go into production. Okay, so mainly three parts you can say. One is the Git part, code versioning and all. One is CI part, and one is CD part. All these three parts we will be exploring in this week in more detail. Not only today's class. This entire week will be for CICD. Okay, so I'm stopping here. Any doubt on this slide? Okay, moving to the next one. So this is the different tools available for CI/CD. So CI/CD is not a AWS service. First of all, CI/CD is a concept, like how to integrate your code automatically and how to deploy your code automatically. Now, in order to fulfill that functionality, many tools are available. AWS provides few tools, and it's not always about AWS. You can use some third-party tools as well. And other cloud service providers, they have their own tools available. So you don't need to remember this. There are a lot of stuff, but don't need to remember it. Let's quickly check what are the tools available. Starting from the code. So in order to maintain your code, Git is the most common and most famous tool. Apart from that, if you don't want to use Git, then you can go with Confluence or you can go with Zira. These are also providing you the code versioning system. Then how to build your code. You can go with Maven, that's more common. Stands for simple build tool. So both will do the similar things. I mean, both will be helping you for the build phase. Then coming to test phase, JUnit, which is mainly for Java testing, Java unit, and SE is Selenium tool. So these two framework or these two tools are used for testing purpose. Then coming to release part, like maintaining different version, which part is released, which one is
Maven is
not
also
released.
framework, right?
Sorry, please come again.
Maven is also framework, right? Which is used in testing actually.
No, not
Maven,
testing. Maven is used for building, right?
building the code. I don't know.
Yeah, you can write your test cases, but for test cases, you need some other framework like JUnit or this one Selenium. And these are not the final list. You may come across many other tools also. Like for
Mhm.
Python, we have PyTest. If you are writing Python code, then PyTest is the framework which can you we can use. If you are working on a Java project, JUnit can be used. And similarly, there are many more test framework available. Does that answer your question?
Yes, yes.
Okay. For the release, Jenkins is the commonly used software which helps you to to create your releases. For the deployment, AWS is there, and there are few services in AWS which will help you to deploy your code. We'll be exploring them in upcoming classes. Docker and Doc OS, these are also third party tools which can help you to deploy something. Then operate, how to operate your you can say your product or software. So Chef is one of the tool. Ansible and Kubernetes, these are other tools which will help you to operate your product. And coming to monitoring, if you want to monitor the performance of your products, so Nagios is one of the third party tool and open source. Splunk is one of the logging tool. It will capture all the logs from your website or from your server, and it will help you to analyze the performance, how the CPU utilization is going on, how the memory usage is going on. Because the code changes you are making, you have to monitor that, whether that is causing any performance issue or whether it is improving the performance, so that you can monitor with help of Splunk. And there is a third party tool, Datadog, available, which can be integrated with many type of projects, and on a very easy to, you can say, monitor in a graphical manner on a particular dashboard. You can very easily monitor the performance of your projects. Okay, so as I said earlier, You don't need to remember anything out of this. This is just to give you an idea, like what are different tools can be used for different phases of your project. For coding, for building, for testing, deploying, monitoring, different tools are available. And this is not the only tool available. There are many more tools available. Maybe for monitoring you will not use any of these three. That's fine. Similarly, for code, suppose you are not using all this thing, you can use svn. Svn is also one of the code versioning tool. Okay, so any doubts on this slide? Okay, let's move to the next one. Git overview. So Git is the mainly more, you can say, most commonly used code versioning system. So maintaining the code on local system is risky. That's true. If you are working on any project and you are writing your code and that's available only on your local system, that's not good. Because suppose you are working from last 3 months and everything is working fine, you have even demonstrated to your client, but just 2 days before your release, somehow you lost the code, or you lost your laptop is broken, your laptop is stolen, then what we will do? That's not a good practice, right? So after writing your code, maybe as a daily activity, at the end of the day you should put your code somewhere on a centralized server, so that there is no dependency on your local system. That's one challenge. There can be another challenge, that developers may be located globally and collaborating the code may be difficult. If one person is working on a project, it's okay, but if 10 person are working on the same project, and sometimes it's possible that multiple people are working on the same file, then how to collaborate that code? Nowadays everyone is working remote, right? How to collaborate the code? Even for that purpose we need a code versioning system. So Git is free, first of all, an open source distributed version control system. You can go to Git website, you can create the Git repository over there, and you can manage your code easily there. You can manage the history. I mean, Git itself will manage the history. It will help you to merge the code, because multiple people are working on same file or sometime different files. We have to merge their code. All these things will be happening with the help of Git commands. Okay, so users can create local repository and push to the server. Repository is nothing like a folder. You create a folder on your system, you make some code files, and you can push that entire folder into the Git server. And users can create feature branches and merge into main branch by creating pull request. So we are using a lot of terminology like feature branch, merging, pull request. What are these things? We'll be exploring and I will demonstrating that practically. So you can see this diagram, maybe this will give you more idea. So this is my Git centralized repository, or you can say distributed server, centralized one. There are three developers. They may be located like in different countries, different location. Developer one working on Java, some Java related files. Developer two is working on Python files, and developer three working on SQL scripts. But those three developers are working on the same project. That means they have to push their code into the Git repo on a regular basis. And not only pushing the code, they have to pull the code also, because other people are pushing the code into the server and that code is not available on the developer one system. That means, as a practice, what we do is every day in the morning we pull the code, so that I can take the fresh code from the server, which was submitted by other developers yesterday, so that I have complete up to date code for my project. And at the same time, at the end of the day, every developer should push their code into the Git repo, so that Git repo should always have the working and complete code. It may be possible that as of now your code is working perfectly fine, but you haven't pulled the code from other developer. As soon as you will pull the code from other developer, and now you will test your code, you will realize that your code is not working because you tested your code individually earlier as a unit testing, which was working perfectly fine. But when you are testing your code with other code changes, with other developers code, it's creating some problem that we have to fix it. That is known as integration test. So every developer should do the pulling and pushing the code on daily basis, and you can run your test cases so that you will know that okay, my code change is not causing any issue, because as a developer you are responsible for your code change. If your code change is causing any problem, any failure, that means you have to fix it. Okay, so this is all about git concept. The next is create a git repo. Okay, so before I start the stuff practically, in case you are having any doubt till now, you can ask me. Let me log in into my AWS account. Give me a moment. Let me add my MFA code. 573890. Okay, that's good. So before we talk about git repo, we'll talk about that, we'll do it practically. We would need one more thing, that is known as cloud 9. And what is cloud 9? Cloud 9 is a developer service provided by AWS. So basically it's a small server. It's a small server and it's free of cost. That server will come up with all the commonly used installed software. That's the difference. Otherwise you may think that if it's a server, then we can simply create EC2 instance, the free version, right? You can do that, but you will not find any software installed on that. You have to install it. On the other hand, if you are going with cloud 9, it is a server, but the commonly used software like Java, Python, Git, all these things are pre-installed. That means that box is ready for development purpose. So let me quickly search for cloud 9, and you can see this. A cloud IDE stand for integrated development environment. That means the tool which is used for writing, running, and debugging your code. You can write your code, you can test your code, and you can even debug. If it's not working as expected and you want to debug it line by line, that's possible. Okay, so we'll click on cloud 9 and we'll